All right, so the topic that we're going to be covering today is simplifying expressions, and we are going to be doing this using the order of operations. Now, just to clarify some basic vocabulary, because I may use this vocabulary and I don't want you wondering what I'm talking about when I'm doing this, let me tell you that a variable, we should know what a variable is by now. It's just a symbol like a letter that represents a number. So we can use any letter. Sometimes we even use Greek letters, all right? So the most common one you see is X or N, most common, but really it could be any letter. A numerical expression is an expression that names a particular number. So in other words, it's something like this. It has all numbers in it, no variables, and it's going to, when you have a numerical expression, you can simplify the whole thing down to one number. We're going to be working on doing that today, taking large expressions and simplifying them down into one number. Now, a variable expression is similar, except it contains a variable. So you could have the same thing, but now there's a variable involved. And you can simplify these, but you're not going to be able to simplify it down into one number. All right? Each of them will simplify to a different extent, but not necessarily to one number. All right, some action words that I use, and these are important for the objectives, so you understand what the objectives mean. In the objectives, I have said that we will use the order of operations to simplify expressions. Here's what simplify means. Simplify means replace a numerical expression with the simplest name for its value. So in other words, take a large numerical expression and simplify it to one number. All right, you may think that this is synonymous with the word reduce. It is not the same as tell me what X is. That action word is called solve. So simplify means to take whatever you have, it may be very complex, and make it as small as possible. All right, how do we know what part to simplify first? Because when you get large expressions, the key is where do you start with all this stuff? Because we know now we're not going to just write the whole thing into our calculator and press equals. And we're going to use the order of operations. So here's the order of operations in review. First thing we're going to do is those groupings. If you have groupings inside of other groupings, go from the innermost to the outside ones. So innermost first, work to the outside. Each of these is a different grouping symbol. So you could see more than just parentheses. You may see brackets. You may see absolute value bars. That means you've got to simplify what's ever inside them first before you find the absolute value. Fraction bar. What that means is that the top is a group and the bottom is a group. May not have any parentheses, it doesn't matter. That fraction bar is a grouping symbol. It makes the top a group and the bottom a group. So it means before you start doing any of that division, you've got to simplify the top, simplify the bottom. After you do the groupings, we move on to the exponents. All right? Third, multiplication and division, but be aware, it's not multiplication first, then division. It's whichever comes first from left to right. There we go, a little clearer. All right? Finally, addition and subtraction, and not necessarily in that order, but whatever comes first from left to right. And these last two items sometimes can be a pain in the butt because you'll want to multiply before you divide. You'll want to add before you subtract, but you cannot necessarily do that. You've got to do the left to right. All right, so let's go to the next page. And we are going to take a look at some expressions that we are going to simplify. All right, so this one is quite the complex expression here. And I'm going to need my calculator. So first of all, my groupings. So the things I want to do first are here, here, and here. That's what I want to do first. So On my next line, I'm going to go down, I'm going to write an equal sign. I'm going to write a 120. 6 plus 4 is 10. Everything else I'm just carrying right now. So times 10. I've got two things in here. I've got a subtract and a multiply. Which is the one I do first? Do the multiply first. So I'm going to underline that. So I'm going to leave my parentheses, leave my 35 there, and 5 times 2 is 10. And then I've got 15 divided by 3. That is 5. Once you've simplified everything inside the parentheses can go bye-bye. All right? Now, I'm still not done with parentheses because as you can see, I've still got this left. So I need to simplify that. So go down 120 times 10 plus 35 minus 10 is 25 minus 5. All right, no more parentheses. Next, exponents, no exponents. Next, multiply and divide. I've only got one of those. That's this. That's going to be my next step. 120 times 10, this is easy. 1200 plus 25 minus 5. I've got add and subtract. Go from left to right. So here's what I'm going to do first. This is going to give me 12, 25 minus 5 finally gives me 1220. All right, if I go to my next problem, I don't have any grouping symbols. But here's what I do have. I have exponents. That's what's going to be first this time. 3 squared means 3 times 3. This is going to give me 9. Then minus 4 divided by 2 plus 1. Out of this, what is next? Divide. So we're going to do this division first. This is where it gets really tempting to do 9 minus 4 first, but you can't. The division has to come before any subtraction. So this is 9 minus 4 divided by 2 is 2 plus 1. All right, this is where people get tripped up. It looks like this is so easy from here on out. And the big mistake people make is go, ooh, 3, 9 minus 3 is 6. No. Adding doesn't come first, it's from left to right. So the first thing you're going to do, 9 minus 2. That gives you 7 plus 1. This is going to equal 8. So don't make some of the easy mistakes to make. All right, next one. I've got multiple groupings. What we want to do is work from the inside out. So the first thing we're going to do is go right here to the innermost grouping. And I've got 5 minus 1. That's going to give me 4. So this equals, I'm going to leave everything here, 3 times 9 minus 2 times 4, bracket. What out of this comes next?
2 times
2 times 4. This is another one of those really common mistakes. People want to do 9 minus 2 and take the 7 and take 7 times 4. No, don't do that. Make sure you're following the order of operations. In this grouping, multiplying comes before subtraction. So we're going to do the 2 times 4. So I've got 3 times 9 minus 8. And now we're still working on groupings. We're going to do the 9 minus 8. So 3, 9 minus 8 is 1. 3 times 1. This gives us 3. All right, let's take a look at D. We've got a grouping. We've actually got 2 groupings. We've got the group that's in the parentheses, and we've got the fraction bar, which says we do the whole top and the whole bottom first. So here's the thing. You can actually work on this in 2 parts. You can work on working on the top, and you can work on the bottom. So on the top, we've got these parentheses. What we need to do first is figure out what gets done first in the parentheses, because we've got exponent and subtraction. And what that's going to be is exponent and exponent. That's what's going to happen first. So let's make an equal sign. I'm going to leave this. 5 squared is 5 times 5, which is 25, minus 3 squared, 3 times 3 is 9. Whoops, parenthesis. Now, I can do the bottom all by itself. 2 squared is 4. All right, go back to the top. I'm just working on the top. I've got parentheses. 25 minus 9. I think 16, right? Okay, so 4 squared. I've got 16 over 4. All right, now, if I go back to my numerator, the two things I've got is exponent and multiplication. Exponent comes first. This is what I'm going to work on. 4 squared is 4 times 4, which is 16. Times 16 over 4. I think 16 is 256? Is. All right. So 256 divided by 4. Tell me what that is. Does anyone do it? 64. There you go. I love when you guys work on your calculators along with me because it saves me having to stop and do it. Perfect. All right? This is not tough stuff. We just need to practice it a little bit, just one day, to get into it before we get into the stuff that has a lot of variables in it. All right? Let's go to the next page, and we're going to talk about another action word here. Evaluate. All right? Evaluate. What this means is replace each variable in the variable expression with its given value and simplify the result. When you're asked to do this, the problem will always look the same. It will have a variable expression, which is here and here, and it will give you values for each of the variables. All you're going to do is take these numbers, plug them in here, and then simplify. All right? You're Algebra 2, so I like to save some steps along the way when we do this. All right? Let me know if you're not following along, because I'm going to kind of rip through this fast. I'm going to put these values in here. So first of all, when I have an x touching a y squared, that means multiply. So x is 3, so I've got a 3. Y squared, I'm not going to put a y and then put the little 2 and do it the next step. It's y squared. Go to y, square it. Y squared is 4 squared is 16. The way I like to write that is like this. So I've got 3 times 16. If you like to do the dot, or if you like to do the little x, that's totally up to you. This is just how you'll see me write something like this. Now I've got minus. X squared, I'm not going to put the x in the little 2. I'm going to go up here. X is 3. 3 squared is 9. So I'm going to put in 9. Then times y, y is 4. Now, I've got multiplication and I've got subtraction. The multiplication is going to come first. 3 times 16 I know is 48. 9 times 4 is 36. 48 minus 36 is 12. All right, B, this is a very complex variable expression. So let's go ahead and take a look at this. And I'm going to write this all out, putting the values of the variables in there. 3 times x times y. So 3 times x, which is 3, times y, which is 4, plus 4 times z, which is 5. So all I'm doing is putting in the values for the variable. Over 7 times y, which is 7 times 4. Next, I've got a minus. Now I've got a whole new fraction. 10x on top, so 10 times x, which is 3. On the bottom, I've got 5 times y, which is 5 times 4, plus 2z, which is plus 2 times z, which is 5. Don't freak out if you think I'm going fast. When we get to stuff you've never seen before, I'll go much slower. Now, Here's the thing. I've got grouping symbols. My grouping symbols are not here. This is not a grouping symbol. This is just multiplication. Because I don't have anything to do inside. The fraction bar is a grouping symbol. The top is a group, the bottom is a group. Over here, the top is a group, the bottom is a group. So notice I have 1, 2, 3, 4 groups to simplify before I go any further at all. All right, so that's what I'm going to do. Here, multiply before you add. So 3 times 3 is 9 times 4 is 36. Plus 4 times 5 is 20. Divided by 7 times 4, which is 28. Over here, 10 times 3 is 30. On the bottom, 5 times 4 is 20. Plus 2 times 5 is 10. I've still got to simplify those numerators and denominators. 36 and 20 gives me 56 over 28. Here I've got 30 over 20 plus 10, which is 30. All right, don't freak out that you've got two fractions you've got to add. These simplify. 56 divided by 28 is 2. 30 divided by 30 is 1. 2 minus 1 is 1. Done. Okay, remember we talked about absolute value being a grouping symbol. Let's take a look at absolute value for just a minute. Remember, the formal definition is the distance between that number and the origin, or 0, on the number line. So in other words, absolute value is always positive. The positive value of what's inside the absolute value cars after you simplify it. So here we go. As an example, the absolute value of a positive number is itself. So simplified, 5 minus 3, you get 2. Absolute value of positive 2 is positive 2. It's itself. Absolute value of a negative number is the positive value of that number. So here I've got 4 minus 9 is negative 5. The absolute value of negative 5 is positive 5. There we go. Absolute value of 0 is 0. One more page of notes today. Evaluate this expression if x is negative 2 and y is negative 3. All right? I'm going to save some steps on this. Sometimes I find that saving steps actually helps me make less mistakes. So here's what I'm going to do. These absolute value bars are grouping symbols. So I've got to simplify what's in there before proceeding. So I have 2. I'm going to write that down. Absolute value of y. Y is negative 3. What's the absolute value of that? 3. So here we go. Times 3. Minus 3 times the absolute value of x. What is x? Negative 2. What's the absolute value of that? 2. So times 2. Plus, now I'm going to leave the little square this time, and the reason why is because it's outside my group. Absolute value of y is the absolute value of negative 3, which is 3. So I've got 3 squared. My next step, my exponent. All right? So I've got 2 times 3 minus 3 times 2 plus 3 squared, which is 9. My next step is the multiplication. 2 times 3 is 6 minus 3 times 2 is 6. Plus 9. Remember, don't get tricked by adding and subtracting in a row. Always follow order of operations. Do it from left to right. 6 minus 6 is 0. 0 plus 9 is 9. All right? I want to take a minute and talk about opposites and reciprocals. On a number line, numbers that are the same distance from 0 but on opposite sides of 0 are what we call opposites. So examples of these are 2 and negative 2. They're opposites. 5 and negative 5 are opposites. 20 and negative 20 are opposites. X and negative x are opposites. All right? You can think of opposites as any two numbers with the same absolute value. 5 and negative 5, both of them have an absolute value of 5. They are opposites. It's like opposites of the same number, but one is positive and one is negative. Those are opposites. Usually that's really easy until you start talking reciprocals. Reciprocals are any two numbers whose product is 1. The reciprocal of a number is 1 over that number. So here's some examples. The reciprocal of 3 is 1/3. 1 over that number. 3 times 1/3 is 1. The reciprocal of a fraction can be found by flipping that fraction. So here I've got the reciprocal of 2/7 is 7 over 2. Just flip it. And if you notice, if I multiply these, I've got 14 over 14, which is 1. Reciprocals multiply to 1. Reciprocals always have the same sign. All right? Both are positive or both are negative. Reciprocals have the same sign. Opposites have different signs. So what we're going to do is go through and we're going to fill in from this column what is the opposite of that number, what is the reciprocal of that number. So first of all, what is the opposite of 4? Negative 4. So let's fill that in. What is the reciprocal of 4? 1/4. What is the opposite of 1/3? Negative 1/3. What is the reciprocal of 1/3? It is 3. Flip it over, it's 3 over 1. 3 over 1 is just 3. What is the opposite of negative 5? 5. What is the reciprocal of negative 5? Negative 1/5. All right, what is the opposite of 0? 0. Here's the tricky one. What is the reciprocal of 0? No, it is not 0.
0 over 1. 1 over 0.
It's 1 over 0. So let's think about this for a minute. Let's go down to the bottom of the page. If I have 1 over 0, this means 1 divided by 0. Anyone want to put that in their calculator? It's an error. Yes, you cannot divide by 0. If you ever want to have a good laugh, Google dividing by 0 on like YouTube. People have made all kinds of funny videos about what will happen to the universe if you divide by 0. Like it imploding and stuff like that. All right, it's just funny. There's like memes and all kinds of crazy stuff. So this is what we call undefined. All right? But here's the thing. 1 over 0 is not a number anymore. So you have to say it is undefined. Here's a tough one for you. What is the opposite of 2.5?
Negative.
Negative 2.5. Okay. What is the reciprocal of 2.5? Well, remember, it's going to be the same sign. So it's going to be positive. It's going to be 1 over 2.5. Now here's the only issue. You don't want to leave a decimal sitting in a fraction. There are some options. There are things we can do with this. You can put it in your calculator, 1 divided by 2.5. All right? And it'll give you what it is. And you can use that. Here's the other answer. Oh yes, this will time out periodically. I don't know why it doesn't think I'm doing anything. All right, if you take 2.5, let's put it in a fraction form. 2.5 is 2.5, right? Fair enough? I mean, that's easy enough. This is 2.5. As an improper fraction, this is 5 halves. 2 times 2 is 4 plus 1 is 5. So this is 5 halves. Now, this is easy to find the reciprocal. Flip it upside down. This is 2/5.